This is Algebra 1, and we are going to do 5.1. Today we're going to talk about inequalities, and we're going to solve them. So, we're going to solve by adding and subtracting only. The other stuff will be, I think, tomorrow. And what we're going to do here is, you guys have to first start off with understanding that the same things that we can do with inequalities, we can do with equations, or have done with equations. But there are some minor differences. Like an equation uses what symbol? What does an equation use? Equals. Equal, right? Equation, equal. It has an equal sign. Inequalities, on the other hand, don't use an equal sign. They use all of those fun symbols here. Okay? Now, I'm hoping every single one of us in this room have had some form of introduction to these before. So we have a less than symbol. We have a greater than symbol. We have a less than or equal to symbol and a greater than or equal to symbol. The difference between less than, greater than, the less than or equal to, greater than or equal to is what? What's the difference between those symbols? What do you see here is different? Yeah, Zach?
One has a line underneath it.
Yeah, these ones have lines underneath it. What you can think of is that it's the other half of the equal sign, so therefore it's less than or equal to, greater than or equal to. We also should have learned that if you had two numbers up here, 3 and 2, what symbol should I use? Or should I say, which way should the alligator mouth be opening? To the left. So if you can think back to your middle school days, maybe even earlier, you guys probably learned it as an alligator mouth. And the alligator always wants to eat the bigger number, yes? So 3 is greater than 2. That's how I read this. 3 greater than 2. That is a valid or true statement, right? Now, guys, we could switch these around. Now the alligator mouth wants to go the other way. So 2 is less than 3. Those are both true, and those both mean the same thing. You guys agree with that? Yep. If you have more cookies than the person next to you, I don't care which way you stand, you still have more cookies. Okay? But become familiar with the words, not just the symbol. It's important, okay? You guys ready to learn what we can do with those? The first up is the addition property of inequalities. If the same number is added to each side of a true inequality, so that means it has to be true in the first place, the resulting inequality is also true. Guys, if you have more money than the person standing next to you, or sitting next to you, and I give both of you $5, did it really change anything? Other than the fact that you still have more money? Or you're going to have more money? No, you still have more money than the person next to you. It's still true. So, look at what we have here. Now look, there's both situations. A is greater than B. And then there's A less than B. If I add C to both sides, the inequality sign is still facing the same way. The side with A is still bigger than the side with B, even though I added C to both sides. In part 2, B is bigger, and if I add C to both sides, B is still bigger. This is still true whether I use greater than, or the greater than or equal to, or less than or equal to symbols. They mean the same thing. So, examples. I want you to solve it and then check your solution. That's an interesting one. Checking. We'll get to that. 22 is what? What is that symbol? Greater than m minus 8. If I wanted to solve this inequality, I want to solve for what? Solve for m. Right now it's m minus 8. What do I do to solve that? Or get m by itself? Add 8. What's 22 plus 8? 30. Greater than m. Done. 30 is greater than m. What other way could I write that if I felt like it?
M is greater than.
Ooh.
M is less than.
M is less than. Guys,
Or
we read it from left to right as 30 is greater than m. 30 has to always be greater than. And or the mouth, right, of the alligator has to be facing the 30. Now it's hard to do on the screen here because I can't do this, but if I was to take this, cut it out, and flip it, the m's on this side, the 30's over here, right? Mm-hmm. But the sign, or the symbol, is still facing the 30. M is less than 30. To me, sometimes it's easier to read this one and understand than the top one. They're both correct. Because I like to know what my variable is, or should I say, 30 is greater than m. Now you have to start thinking about what are the values of m. If I said m was less than 30, well then right away you're like, oh, 20 will work, 10 will work, 29 will work. But if I say 30 is greater than m, it's not as clear to what m is going to be. At least in my mind. They are the same thing. Both are acceptable answers. It wants you to check that. The only way that we could say is check it, because it's not like 30 is the answer. 30 doesn't work, guys. You can't use 30 because it can't be equal to 30. So pick a value that works in there. What is less than 30? Give me a number.
1.
1. 1 will work. So, check it. Is 22, going back to the original, 22 greater than 1 minus 8? What is 1 minus 8? It's negative 7. Is that true? Is 22 greater than negative 7? Check. It works. I like that. Guys, try part B, please. So, in part B, what do we have to do? Add 14. To both sides, yeah?
Yes, sir.
This is gone, so D is greater than or equal to? Negative 5. Hey, do I have to flip that one? No. So, how do I check it? What's a nice number bigger than negative 5?
1.
Oh, 1 will work. What's even nicer than 1?
2.
Huh? No, I heard it over there. What? 0. Guys, use 0. 0 makes a lot of things disappear. I like 0. 0 is less than or equal to negative 5. Is that true? Check. Next up is set notation. Now, I'm showing this to you guys because the book wants us to put our answers into set notation. It also starts to standardize the answers that we give. Now, if you think back to both of our answers from earlier, m was less than 30 for part A. And part B, you guys said D is greater than or equal to -5, was it? Okay. We gave the answer here. I already got the notes for it here. Is that the set notation from part A is this thing right here. It reads as the set of all real numbers of m such that m is less than 30. That's how you say it in words, but it's written out a lot shorter. So, what we have there is this squiggly line, kind of bracket, and they put m there because we're going to talk about the variable m. And it also kind of helps stand for this whole idea of the set of all m's, all numbers m. And then they put a straight line. That straight line is what we use or say is such that, because it's not all m's. I can't put all m in. It says it's supposed to be less than 30. So therefore, I put my restraints in. M has to be less than 30. You always put your variable first. So m is less than 30, yeah.
You can dock us points if we don't.
If it still makes sense, I'll let it possibly go. But I would start to write things in with the variable first. So flip it around if it needs to be. So, we're talking about m such that m is less than 30. That's what the answer is. All m such that m is less than 30. So it's always the most restrictive part is at the end here. You know your answer is 30 and below. Or not even 30. Below 30. Can't be 30. It's not equal to. So, go out on a limb and do the part B here in interval, or set notation, sorry. Set notation. Interval notation, something different. So, what are we going to get? What should this one start off with? Bracket D such that D greater than or equal to -5 and your bracket. Done. For all D such that D is greater than or equal to -5. Those were all the acceptable answers are. Next up, if there's an addition property, then there's more than likely a subtraction property of equalities. If the same number is subtracted from both sides of a true inequality, then the result is also true. Again, if you start off having more or less than someone else, and you both take away the same amount, then the same fact that you have more or less than them is true. Okay? That's what it comes down to. So here's our example. P plus 8 is less than or equal to 18. What do I need to get P by itself? What should I do? Minus 8. These are gone, so P is less than or equal to 18. Hey, wait a minute. This is multiple choice. That's not 18. What's it supposed to be? 10. It's multiple choice there. You need to figure out which one of them is the correct set notation. So, P is less than or equal to 10 is the limitation, right? That's generally the back of it. The front of it should be what? What should the front be? What letter are we using? B. Which is letter? Careful. Watch your signs. It's G. There's no P up there for a choice. Careful, guys. Careful, careful, careful. Okay, questions on that?
No, sir.
What if I ask you to graph your results? So, I don't know why it's separated like that, because on the slide it became 2 pages, but that's okay. Graphing inequalities. I got a 3-step, no-fail system. Write this down. Number 1, solve the inequality. We just did that about 15 times there. You need to plot the anchor point, the number that you're given. Is it open or closed dot? I'm going to have to go back up to the first page, recycle on that one. 3, check a point, usually 0. Then shade the direction that works. If it don't work, shade the other side. I'll get to that in a second. Okay, so I said I had to come back to this stuff. If I'm graphing, guys, or even talking about how we've already talked about x is greater than 30, or I forgot what the other one was, d is less than or equal to negative 5. When I say I'm greater than 30, what does that mean? If I'm greater than 30, can I be 31? Can I be 28?
No.
Can I be 30?
No.
Why?
Because it has to be greater than
Yeah, it's not equal to, and 30 is not greater than 30. So, therefore, if you see less than, greater than, they are open dots on graphs. If you see something that says equal to, like d is less than or equal to negative 5, you can be at negative 5. So they use a closed dots. Okay? So I had to circle back to that one. Guys, if I can't be at 30, can I be at 30.00001?
No.
Yes. Now, I'm assuming some of us in here have siblings. And either we've done this to our siblings or our siblings have done this to us. They walk up next to you and they just hover their finger over the top of your shoulder or your face or something. And then they say, I'm not touching you. Yes?
No.
You guys have never encountered something like this.
No.
It's the whole annoying your brother and sister, vice versa.
No. So they'll make a message.
Okay. So essentially, it's like that situation though, guys. What it'll be is that you get right up to it, but you don't actually go there. And so that's why you can't be there. It's an open dot, but you can be right up to that particular point. Okay, going back to what we had to talk about here. Next point there. So now that hopefully makes this open and closed dot anchor point. Makes sense. Anchor point would have been the 30 or the negative 5. Checking a point, guys, I'm going to use 0. And it says shade the direction that works. And if it don't work, shade the other side. Hey, guys, if I had a coin in my hand and I flip it and I said it's heads, then it's what?
Heads.
It's heads. If I flip a coin and I said it's not heads,
It's tails.
it's tails. Why do you guys know this?
Because it's the opposite.
Because it's common sense.
Because there's only how many sides? There's only 2 sides that you're going to land on.
So it's not
Now.
together.
Right. We're going to have number lines, guys. If it's not to the left, then it has to be to the right, and vice versa. Now, one of our problems, again, was x is greater than 30. And the other one was d, I don't think it was x. D is less than or equal to negative 5. So we're just going to use these. So we already solved them. Because the solving's different skill. The anchor point, guys, is your number. What's the number in the first one?
30.
30. I'm not looking for over-the-top graphs. I'm only looking for the essentials. The essential of x is greater than 30 is the point of 30. So I put 1 tick mark and I put 30. Is 30 going to be open or closed? Can I be there or not? It's open because I cannot be 30.
I remember doing this.
Now, third part, sorry. Check a point. There's a one point that I would love to use as long as it's not my anchor point, and that would be 0. On the large scheme of things, is 0 to the left or to the right of this 30?
Probably to the left.
To the left. On number lines, numbers get bigger as they go to the right. So 0's someplace over here. Don't know where, but it's over there, right? So the question is, I'm going to check it. Is 0 greater than 30?
No.
No. So if 0 doesn't work, that means the other side will. And I shade that way. I put a squiggly line because it's a lot easier to see than a solid line, especially if you only got one color. Okay? What's my anchor point?
30. Negative 5.
It's negative 5. Open or closed?
Closed.
Whatever you want.
Closed. Choosing 0 again.
Put her on the right side. Left side.
Is 0 less than or equal to negative 5. Is that true?
No.
So does this point work? No, so I shade the
Left side.
left side. Let's do a problem that does work. B is greater than negative 3. Anchor point? Negative 3, open or close?
Closed.
Open because it's not equal to. 0 is here. Is 0 greater than negative 3? So I shade the side that works. The last one is I want you to solve the inequality and graph it. Is what happens if there's variables or aka numbers on both sides. Just gather up your like terms. What's smaller, 9n or 10n? So remember, when we talk about variables on both sides, we try to move the smaller variable, which means subtract 9n from both sides. Negative 1 is less than 1n, or n. Switch it around. I want set notation. What is this going to look like? Set notation. Bracket n
Line.
such that
Negative or n.
n,
Left side.
no,
Greater than.
greater than
Negative 1.
negative 1.
Line.
Bracket. Graph it. What's my anchor point? What's my anchor point?
Negative 1.
Negative 1. Open or closed? Open because no equal sign. 0 is over here. Is 0 greater than negative 1?
Yep.
So I'm going to shade that direction. Done. I'll skip over B unless you guys want me to do it.
No.
No? You think you guys got this? All right. I don't think there's anything else.
No.
Have a great day.